We're now going to look at solving quadratic equations algebraically. It saves us having to draw a sketch if it's not drawn out for us already, and is in some ways a lot simpler way than using a graph, a more accurate way than using a graph as well. Okay. What we need to understand for this is two separate things. We need to be able to factorise. That's the first thing, because we're going to use factorising to help us solve quadratic equations. And we need to have an understanding of the number 0. Okay, just going to have a wee look at a couple of things. I'll rub this back out so that I've got room here. It's just so I've got some space. In fact, see if I scroll down, give myself a wee bit more room. Okay. In fact, I'm being silly. There we go. Nice blank page. Okay, if I take any two numbers, if I take 5 and times it by something and get 0, what must that something be? That something must be 0. If I take 0 and times it by any number at all, I need to get 0, because anything times 0 is 0. This works another way. If I have two letters, if I do two things times by each other and get 0, then either A equals 0, or B equals 0, or A and B equals 0. That's the only way I can multiply two things together and get 0, is if either one of them is 0, the other one is 0, or they are both 0. And that's the whole idea of solving a quadratic equation, because we're looking for the roots, we're looking for when they're equal to 0. And the whole idea is if you're multiplying two things together, only works with multiplying. If you're multiplying two things together and you get 0, one of the two things that you're multiplying must be 0. Could be they're both 0, it could be just one 0, but one of them must be 0. Okay? Only way you can multiply to get 0 is if one of the two numbers is 0. Looking at these then, so these ones have already been factorised for us. So here I've got something times something equals 0. So that means either x equals 0 or x plus 4 equals 0. It could be that they're both 0, but we've definitely got one of them is 0. If I keep going here, I've got the x equals 0. I want to get a value for x here, because we haven't solved an equation until we've got x equals. X plus 4 equals 0, got plus 4 here. Take it to the other side. X equals 0, x equals minus 4. Looking at the next one, again, it's already been factorised. So I've got something times something equals 0. So that tells me either x plus 4 equals 0 or x minus 4 equals 0. Solving both equations, if x plus 4 is 0, then x is minus 4. If x minus 4 is 0, then x must be 4. Last one, same idea again, it's already been factorised. So it's written as something times something. So either 2x minus 3 equals 0 or 3x plus 7 equals 0. Lost my equals 0 then, that's a bit better. Okay, looking at the first one then, 2x minus 3 equals 0. Take my 3 to the other side, here it's a minus 3, so it becomes a plus 3. Here I'm timesing by 2, so I need to divide by 2. So I get x equals 3 over 2, going back up to the other one. I get 3x equals, here we've got a plus 7. This goes over, becomes minus 7. Here I'm timesing by 3, so I need to divide by 3. So I get x equals 3 over 2, or x equals negative 7 over 3. We just need one extra step to add into this then, and that's when we need to factorise ourselves. When we're factorising, we need to remember C, D, T, common factor, difference of two squares, trinomial. You can think of your trinomial now as a quadratic, that's its proper name, rather than a trinomial. First one then, we've got x squared minus 3x. First thing I look for is a common factor. I've got a common factor of x. Take out my common factor of x, I'm left with x minus 3. So x bracket x minus 3 equals 0. That gives you my two things multiplied together. So separate them out. X equals 0, x minus 3 equals 0. So we get x equals 0, x equals 3. Next one, bit of a hint here, where they're all common factors. in example 2. Common factor this time of 2x. That leaves me with 4x minus 1. That's equal to 0. I've now got it written something times something equals 0. So I can separate it out. So I get 2x equals 0. 4x minus 1 equals 0. 2x is 0. We're now following that same principle as before. You've got 2 times something is 0. So the something must be the 0. 4x is 1. Take that minus 1 to the other side. It becomes positive 1. Here I'm timesing by 4. So divide by 4. So I get x equals 0. X equals a quarter. Okay. Last example with a common factor then. Here we've got 28p plus 12p squared. Looking at the numbers first, we've got 28 and 12. Biggest number that goes into 28 and 12, I don't want an equal sign negative to that, is 4. I've got p and a p squared, so I can take out 4p. 4 times 7 is 28. 4 3s are 12, and we need I've now got that written as something times something equals 0, and don't forget your equals 0 here. So I can separate it out. So I get 4p equals 0 and 7 plus 3p equals 0. If 4p equals 0, then p equals 0. 3p equals, take my 7 to the other side, become a minus 7. Here I'm timesing by 3. Oh dear, it's not my day today. So here I need to divide by 3. So we get p equals 0. P equals minus 7 over 3. Now, you might want to stop there and have a go at common factor. If you're quite confident at factorising, I would suggest keep going. Okay, our next kind of factorising then, our CDT. We've done common factor, we're going to look at difference of two squares. Okay, reminder, a difference of two squares is when you have a square number take away another square number. And you get the square root of each, 1 bracket plus, 1 bracket minus. Oops. So if we're looking at x squared minus 9, square root of x squared is x, square root of 9 is 3. So we get x plus 3, x minus 3. That's going to be equal to 0. I've now got something times something equals 0. So I can separate out my brackets. So I get x plus 3 equals 0, x minus 3 equals 0. So we get x equals minus 3. X equals positive 3. Next one, still a difference of two squares. 4a squared is a square number, 25 is a square number. So I get 2a minus 5, 2a plus 5. That's going to be equal to 0. Separate out my brackets. 2a minus 5 equals 0, 2a plus 5 equals 0. 2a equals 5, so a equals 5 over 2. Other one. 2a equals minus 5, a equals minus 5 over 2. Your answers when you're factorising by a difference of two squares should always come out as the same, but with opposite signs, because it's the same thing in the bracket, but with opposite signs. This one, don't have a difference of two squares here. Well, I don't have a difference of two squares here yet. I have a common factor first. Take out my common factor. 2 bracket x squared minus 4 is equal to 0. Now I've got a difference of two squares. Square root of x squared is x, square root of 4 is 2, so we get x minus 2x plus 2. Now see this 2 here. This 2 here outside the bracket makes absolutely no difference. Okay, I could take that to the other side, do 0 divided by 2 and get 0. So I can completely ignore that. I'm only interested in what is inside the brackets. If we have a number, not a number, a letter outside the bracket, if our x is outside the bracket, then we need to consider it as one of our roots. If it's just a number, we just ignore it. Right, if x minus 2 equals 0, so x is 2. X plus 2 equals 0, so x is negative 2. Okay, again, if you're not 100% confident with your factorising, you might want to stop there and practice ones where it's just difference of two squares. I'm going to keep going on to trinomials. Still need to consider CDT. We always need to consider if there is a common factor, if there is a difference of two squares. First one there isn't, So we're going straight to our trinomial. Okay, so we're looking for two numbers that multiply to give minus 12, because we've got minus 12 at the end, add to give minus 1. That's got to be 4 and 3. One of them needs to be negative. I want minus 1, so I want minus 4 plus 3. So we get x minus 4, x plus 3 equals 0. That's going to really annoy me that my equations aren't in line now. I'll try and get over it. So we get x minus 4 is 0, x plus 3 is 0. That gives me x equals 4, x equals minus 3. Looking at the next one, we're looking for numbers that multiply to give minus 6, add to give 1. That's got to be 3 and 2. I want positive 1, so minus 2. That must be x minus 2, x plus 3 equals 0. So x minus 2 equals 0, x plus 3 equals 0. So x is 2, or x is minus 3. Try the next example. No, I've lost it. Oh, there we go. Number 5. Same idea, it's just the factorising is getting trickier this time. So we've got 5x squared plus 14x minus 3. Might be a while since you've done one of these. Okay, take the number at the beginning, we take the number at the end, and we multiply them. So 5 times minus 3 gives me minus 15. So we're looking for two numbers that multiply to give minus 15 and add to give 14. Okay, must be 15 and 1. So looking at factors of 15, we've got 1 and 15, 3 and 5. The only one that's going to give us 1 and 15. I want minus 15, so one of these must be negative. I want positive 14, so it must be minus 1. Now, because I've got my 5 at the beginning, I need to look at what cancels out. So I've got 5x over 15, 5x over minus 1. Next, look for cancelling. 5 goes into 15 3 times. 5 and 1 don't simplify. So this is what goes into my brackets. So I'll get x plus 3, 5x minus 1. I know some of you use a different method for this kind of factorising, so just stick with the method that you're used to. It makes no difference the method that you use here. You only get marks for the brackets. I've got my two brackets, I can separate them out. So we get x plus 3 equals 0, 5x minus 1 equals 0. So x is minus 3, 5x is 1, x is a fifth. So there are two answers. Okay, next one. We've got 1 minus 5x minus 6x squared. So we get minus 6x squared minus 5x plus 1. Just writing it round the other way. Similar to the last one now. I need to multiply my two numbers together. That gives me minus 6. So I'm looking for two numbers that times to give minus 6, add to give minus 5. So factors of 6, 1 and 6, 2 and 3, bit tricky this time. They'll both give me minus 5, but I want minus 6, so I need them to have different signs. Here I can do minus and minus to get 5, but I can't do plus and minus, so it must be 1 and 6. I want minus 5, so I want minus 6 plus 1. I need to check and see what cancels again, because in front of my x squared I've got minus 6. So I get minus 6x over 1, and I get minus 6x over minus 6. So here my minus 6's cancel, and the negatives cancel as well, because a negative divided by a negative is a positive. So in my brackets I get minus 6x plus 1 and x plus 6 equals 0. So we get minus 6x plus 1 equals 0, x plus 6 equals 0. So I get minus 6x is minus 1, dividing by minus 6. Minus 1 divided by minus 6 gives me positive a sixth, and x plus 6 equals 0, but x equals minus 6. Never seen one as tricky as that in an exam. I'll leave you to practice some of these then.